Okay. Hi, everyone. Happy Monday. Happy week 10. So usually I start with a dog picture, but today I thought I would try to give you some helpful hints for the final instead. Probably not as cool as a dog, but so the first part is that there will be a final review session this Thursday from 7 to 8:30 p.m. in 370. We won't be recording it, but the slides will be online. And that'll be led by SL Zach and Nolan, so definitely come out and see that. Okay. Additionally, we have posted a bunch of practice finals, very similar to the practice midterms. I would strongly suggest that you try to do as many of these as you can, and actually sit down and do them, because these are very similar to the exams that the exam that you will see. These are just previous quarters final exams. So the best way to study is by doing some of these exams. Actually try writing out the problems instead of just coding them up in code step by step, because it's a different experience, that sort of thing. Okay. So you will get a syntax reference sheet. It looks like this. So it's very similar to the midterm reference sheet. The two big differences are there's no big O, but you won't be asked questions about big O. And even if you were, you know how all these things are implemented anyway, so you should be able to figure that out. And then the second part is that we've added all of this graph stuff. So you have stuff about vertices, edges, and some pseudocode. So we give you a lot of information. The exam is open book, just like it was last time. We will have, the 20 books that we had last time available to you, so don't worry if you don't have your own book. And then, so here's what an actual exam will look like. It's going to be around 10 problems, a mixture of reading code and writing code. So you might see something like this, where you have to do some binary search. Do you remember is where you split the array in half each time you search? And then you might have to do something with selection sort, merge sort, that sort of thing. You won't have to write the code for it, but you would have to understand how it works well enough that you can kind of trace through what's happening. Additionally, more merge sort stuff. You might have to do a linked list read problem, so understand what a piece of code is doing to a linked list. You'll also have to write linked list code potentially, kind of the flip side of that. So make sure you've practiced tracing through pointers and that sort of thing, because that will definitely be on the exam. Binary search trees, hopefully you remember those. You might have to simulate adding to a binary search tree or moving from a binary search tree. Do you remember? Maybe look at those slides if you've kind of forgotten how that works. And then you might have to do something where you write, not necessarily for a binary search tree, but for a binary tree in general. So making sure that you understand how traversals work, and understanding which traversal to use when, because almost most binary tree problems can be solved with some kind of traversal. Then looking at heaps. So you had to implement a heap for PQ, right? So understand how inserting into a heap works, deleting from a heap works, that whole bubbling up, bubbling down sort of thing. Graphs, right? And then going through, understand some of the terminology for graphs, what's a connected graph, what's a directed graph, that sort of thing. And then also make sure that you can trace through the various algorithms that we talked about. How would Kruskal's work on this? Well, Kruskal's wouldn't work on this graph because it's directed. But how would BFS work on this graph? How would Dijkstra's work on this graph? And then you might have to write a function that has some sort of, that takes in a graph and does something to it. So make sure you understand how to iterate through edges, how to iterate through vertices, how to write out your search algorithm of choice, that sort of thing, because you might see any of those on the exam. And then the last part, or one of the last parts, has to do with inheritance and polymorphism. So this would likely look something like this. We'll see an example of this later today. So don't worry if you don't yet know how to solve this, because that's what today's lecture is for. And then you might have to do something where you're like writing classes, that sort of thing. So understanding how inheritance works both as a client using inheritance, like here, and as somebody who's writing and designing classes. Some things that won't be covered include any sort of drawing of fractals. You might still see recursion or recursive backtracking, so be prepared for that. The whole multiple inheritance thing and private inheritance that we talked about last week will not be on the final. The normal public inheritance would be, potentially. Overloading operators, anything not part of the Stanford library, that sort of thing. So for the most part, everything that you've seen in the class through today is fair game for the final. The emphasis will be on the stuff past the midterm, though it's very difficult to write a tree question without using, for example, recursion, right? Because basically trees are fundamentally recursive. So the class is by its nature cumulative, though expect to see more stuff on linked lists, trees, graphs, inheritance, that sort of thing. What questions do you have about the final? Topics that might be on it? You're like, damn, this is less than a week away. Sorry, I just ruined your Monday. Okay. Yeah, please do come out to the review session. It'll be lots of practice problems, that sort of thing. And then really spend some time going through some of the practice exams. Also, Amy and I will continue having our office hours like normal this week, which means that there will be office hours Thursday and Friday. That will just be for the exam questions, because your homework is due Wednesday. So please come to those if you have any sort of exam questions, or even just hang out there and do a practice final sort of thing. Yeah.
Is there going to be anything explicitly from one of the midterm, file reading or something?
So the question is there going to be anything explicitly from before the midterm, like file reading? So file reading was not on the midterm, it was explicitly excluded, so I believe, right? Or it wasn't? Okay, that was last quarter, sorry. So you might need something like file reading, but it wouldn't be the way the problem would be set up is not, demonstrate that you can read a file. It's more like you need to use a file to read in a graph or something. So you definitely will still need to know ADTs. You definitely still will need to know recursion, string manipulation, that sort of thing. Cool. Any other questions? Okay. So with that in mind, let's talk about polymorphism. So the idea behind this lecture is, remember how on Friday I said there were kind of two uses for inheritance? So one was from the class writer's perspective, which was you get all of this reusable code, right? So you don't have to write as much of your own code because you just get all of these methods for free when you inherit, which is great. The other reason, and probably one of the better reasons for inheritance, is that clients can treat two objects that are a little bit different in the same way. So basically what that means is you can have a bunch of different animals, for example, and you can order each of those animals to speak. And each of those animals might speak in a different way. Like some of them might quack or woof or whatever, based on if they're a duck or a dog. But you still get to call speak on all of them. So the client doesn't need to know, okay, am I currently dealing with a dog or am I dealing with a duck? They just know that this is some kind of animal, and because it's an animal, it has an ability to speak. So the client actually gets to reuse a lot of code on all of these different animals. Or more generally, it gets to reuse code on subclasses of some primary class. So basically what that is polymorphism. So this comes from the Greek word of poly, which means many, and morph, which means form. So it's many forms. And it means that you can run the same code on different objects and get different behavior. Okay. So does that kind of make sense? Like, this is why you can call like draw on a G oval and on a G rect, and they'll both draw something, even though what it's actually drawn is different. Okay. So in C++, what this looks like is you have some sort of pointer to something that, so the pointer would be the superclass, and the actual like declaration is the subclass. This example, the third one, so the first two are from Friday, where we saw the employee classes, right? There's like the employee, the lawyer, the patent lawyer, and the programmer. So the third one is actually from Trailblazer. So inheritance is used in the real world, where all the different kinds of maps, like the terrain and the maze and all those different maps are just subclasses of world. So you can use any of them and call DFS on any of them, sort of thing. This is why the whole virtual thing was so important. If you remember talking about that, I know there are some questions about that. Basically, what virtual allowed us to do is it allowed us to, if we did have something like Edna equals new lawyer, when we called Edna.salary, we would get the lawyer's definition of salary, not the employee's definition of salary. So that's why we were using virtual for everything. One of the downsides of inheritance is that you can't call any lawyer-only member functions on Edna, right? Because Edna, like the compiler just knows that Edna is an employee, and it's only when it's actually running that it would realize that it's a lawyer and not just an employee. So you wouldn't really see like this too frequently. You'll see this in some of our examples where we test you on inheritance, but this isn't really how people would use inheritance in the real world. So there are kind of two main ways that they do it in the real world, which is the first one is having methods that take in an employee, but you can pass in a lawyer or a programmer or a patent lawyer instead. So in this case, this is actually from our code on Friday. Do you remember I was printing out all that stuff about like salary and vacation forms and that sort of thing? And so this was the method that I was using to do that. So I didn't need to write a specific one for lawyers and patent lawyers and programmers. I could just use the employee one for all of them. So this is why you couldn't call like a specific lawyer-only method in this function, because if you were to try to do that, like this function has to be able to deal with any sort of employee, not just lawyers, right? So that's why you couldn't, even though, if we were to pass in a lawyer, like we know that's a lawyer, but the program has to be able to run this function on any employee. Okay, and then the other common use is you might have a collection of employees, but each element of that collection might be like a more specific subclass. So you can imagine this might actually be something similar to what a real workforce would look like, where your workforce is made up of lawyers and programmers, but you would just have them in a collection of employees. And so if you wanted to do something like find the budget for all of them, you could just call salary, and it will use that specific implementation of salary, not just the generic employee salary. What questions do you have about about polymorphism? Why we'd want to use it? Why, how we generally use it? Nope. Okay. Cool. So I was saying that you couldn't call, Sue on a generic employee, right? So the way you can get around that is you can get back this extra functionality by casting. So what casting does is it temporarily changes it temporarily says that this variable is of type whatever I'm casting it to. And the compiler will just trust you. So even if it's not actually of that kind, it'll just trust you. And so what that means is, for that one line of code, you can treat that variable like whatever you want, right? So in this case, Edna is really a patent lawyer, but if we were to call, file patent, the compiler doesn't know that Edna is really a patent lawyer. The compiler's like, oh, I just hired Edna to just be a plain lawyer. And plain lawyers don't know how to file patents, so I don't think Edna knows how to file a patent. But if we tell the compiler, like, oh, look, Edna's actually a patent lawyer, then you can then call file patent. But, you know, like the very next line of code, Edna is no longer considered to be a patent lawyer anymore. Edna would be considered to be a lawyer again. Yeah? Yeah, so the question is, like, why wouldn't you just call Edna a patent lawyer from the start? So that has to do with, like, so again, these are a little bit contrived where we're creating these pointers explicitly. You might think of it as Edna is a, you know, like actually in a vector of employees. And so you might have some sort of if statement that's like, oh, if Edna is really, like, you know, you call some function on Edna to get the subclass of Edna, and then you would say, like, if Edna's subclass is patent lawyer, then call file a patent. Otherwise, if Edna's subclass is, like, lawyer or something, right? So that would be more the situation you'd see it, and you wouldn't really see it looking like this code exactly. Great question. Yeah? So the question is, like, how do you check what the subclass is? I'm not 100% sure how to do it in C++. I'm sure there's a method for it. I know in Java there's something like is instance of or something, and you put in the class, and you call it on the object itself. You could also do something like maybe the employee has a method that's like returns a string of what kind of employee it is, and all of the subclasses of employee would override that. So that's one way to do it. Cool. I thought there was another question. Okay. Cool. Okay. So this, remember how I said that the compiler will just trust you if you say that an object, like if you say an object is of whatever type, it'll just trust you. That's because it kind of assumes that you're smarter than the compiler is. The problem with this is if you try to cast an object to something that it's not, so something that it's not, you know, itself or like a subclass of, then you'll get unpredictable behavior or a crash. So your program might not crash, maybe it'll just do the wrong thing, but you definitely want to avoid something like this because it will lead to very unpredictable behavior that's difficult to debug. So this happens if you cast a lawyer object to a programmer, or if you were to cast a lawyer to a patent lawyer and it's not really a patent lawyer behind the scenes. So kind of both types would break. Yeah?
If you were to define Edna as an employee, would you pass her as a lawyer?
Okay, so we're saying Edna is an employee. Okay, and then
You could cast her as a lawyer, right?
yeah, so you could say like, so this is totally fine. You could say something like this, and that's totally fine, because all patent lawyers are lawyers. So this is sort of like, if you remember me talking about this Lipskov substitution principle, this is why, because you need to be able to treat these objects like, you know, they're superclass. Yeah.
Could you normally just use
So if we didn't cast, could we use Sue? But are we keeping employee here? Okay. So, so if it looks like this, can you just call Sue? And the answer is yes, because Edna is, like, the compiler knows that Edna is of type lawyer. So you can call Sue because all lawyers can sue. Great question. Okay. I know casting's a little bit tricky, so are there any other questions? Okay. So we're going to be doing one of those examples where you basically just trace through what happens if you call different methods on different combinations of like subclass and superclass. So I copied this onto that whiteboard. I hope you can see it. The whiteboard wasn't very big. So The big takeaways here are every method will always be declared virtual. We will not test you on non-virtual inheritance because it's tricky and shouldn't ever be done anyway. And then additionally, we won't try to trick you with the output. So we aren't going to have something where like Snow's method 2 prints sleet 3 or something. Like that's not that. We're really trying to just test that you know which methods are called. That said, we might have something like this here, where we are calling another function inside that method. So in that case, you might get some different output, but that's because we're calling this other function. And this is like these rules apply to any of these inheritance problems that would be fair game for the exam. Yeah, so hopefully you can see that. The only tricky one is like the one that I circled because it calls Snow's method 2. Okay, so a good approach when you see a problem like this is to start off by just writing out like which, like to find the hierarchy of inheritance. So what's inherited from what, and then also write down the methods that each one has and whether they're inherited from a superclass or not, right? So in this case, what's the top superclass? Snow, right? That's the one that doesn't inherit from anything. Okay, so we have Snow. What methods does Snow have? Yeah, 2 and 3. Okay. So what are the, what's something that inherits from Snow? Sleet, okay. So what methods does Sleet explicitly write itself? Yeah, 2 and, wait, sorry, 1 and 2. Does it inherit any methods from Snow? Yeah, so I'm going to put the 3 in parentheses so we know it's inherited. Okay. The other subclass of Snow is fog, right? No, sorry, is rain. So what are the explicitly written methods of rain? Yep, 1 and 3. And it inherits 2 from Snow. Okay, and then fog is a subclass of sleet. So be like that. And then it has methods 1 and 2. And so it inherits 3. Cool. What questions do you have about that? Yeah. I don't think so, unless I wrote it down wrong on the board.
I think so, yeah, because on the PDF it says
Okay, sorry. Darn it. Okay, well, it would have method 3 instead of method 2. Sorry, let me change it here. That is the rest of the board correct? Yeah. Right. Okay. That's what I get for trying to write all this in 10 minutes before class. Yeah.
I'm really sorry to ask this, but like, are you recording?
Yes.
Okay, sorry. I just didn't see it. I was really paranoid.
Yes, I am recording. Should be recording at least. Explicit. Hold on. Yes, I am recording. Good call. Yeah. My pretty diagram went away, but it looks like this. Yeah. Okay. So, okay. Kind of the first thing you want to do is figure out what the class hierarchy is. So we know that Snow is the parent class because it's the one that's not inheriting from anything. And then The subclasses of snow are sleet and rain. Rain. And then fog is the subclass of sleet. Okay. And then what you kind of want to do from here is try to figure out which methods each one explicitly has. So snow explicitly writes 2 and 3. Sleet explicitly writes 1 and 2. Fog explicitly writes 1 and 3. Good catch. And rain explicitly writes 1 and 2. And then you want to figure out which ones are inherited, right? So which ones it has access to that but didn't explicitly write. So in this case, every subclass of snow is going to have 2 and 3. So that means that sleet must inherit 3, rain must inherit 3, and fog must inherit 2. Yeah.
So when it says snow, like colon method 2, what does it mean?
We will get to that. Great question. Yeah.
So if fog is inherited too, it's inherited 2 from sleep, right?
Yes. So the question is, when fog inherits 2, what 2 is fog inheriting? So it's inheriting it from the most, or from the closest superclass, which would be sleet and not snow. Okay. What questions do you have about just making this diagram? Okay. So let's talk about kind of this in the context of how we would solve these inheritance problems. So if you're given something like this, which like you likely will be on the exam, you have to figure out what output is generated. So kind of the way you want to do that is you want to start off and look at the declared, which is the blue type, which is on the left side of the equal sign. Whoa. Sorry. And then the right side of the equal sign is the initialized type. So if you look on the left side, you want to see, does that variable have a member of that type? So does sleet have a method 1? And in this case, it does. So there would not be a compiler error. Then you go down and see, like, okay, so what is the initialized type, which is the right side of the equal sign? So in this case, it's fog. So you go and you look at fog's method 1. Okay? So, okay. Now, getting back to your question, what should we do if you have this, like, these other function calls inside? So there are 2 different kinds of function calls that you can have. So the first is where you, like, you have the class name here. And in that case, go to that class and execute that class's code. If that class doesn't have that code, like let's say we called, let's say we called rains, or sorry, I don't know. Yeah, let's say we called like sleet's method 3. Because sleet inherits method 3 from snow, we would just use like snow's method 3 because that's the same as sleet's method 3 because sleet inherited it. If you don't have a class name, if it just says method 3, you use the initialized types method. So it doesn't matter which class we're calling it from, that's kind of how you decide. So you either go to like, yeah.
Can you sort of jump out of your chain of inheritance? Like, can I run rain's method 1 from sleet?
So the question is, like, can you jump out of the inheritance? Like, can you call like rain here from sleet? And the answer is no, because they aren't directly related to each other. So it's like invalid to call a member of something that's like not actually, right? It'd be kind of like, you might call like goval might have like an is round function or like is circle function, right? If it's the same width and height, and you can't really call that from a rectangle because that doesn't make sense. Cool, yeah.
So in this case, we go to snow to execute the second method, but because in the previous
So the question is this a continuation of what we did before? Doesn't really matter. This would just be like a method 2 somewhere in one of these classes. Yeah. Yes.
Here we're calling method 3. What if the initialized type doesn't have method 3? But so we're kind of like using the method from the upper class, from the super class, sorry. And would that work if we don't call column method 3?
Okay, so the question is, what if we're trying to call method 3 and the class that we're writing, or the class that this is a method in, doesn't have a method 3? What happens then? So in that case, you would use the superclasses method 3, like you were saying, and it'll automatically just work because the subclass has all of the methods that the superclass does.
We would have to call snow column.
No, so it wouldn't have to call snow : or anything. It'll just use the one of that.
So why are we
Initialized type.
calling snow column?
So then the question is like, why would we call like snow : And the reason we do that is it's kind of like what we were doing last week where we had like the salary of a lawyer was twice the salary of an employee. Like we might have a specific method we're trying to call. So that's kind of where that's coming from. Did you have a question?
So do you still follow the virtual statements
So the question is, do you still follow the virtual statements when you call method 2? So in this case, you always will execute Snow's method 2. It doesn't matter if Snow's method 2 is virtual or not. You always call Snow's method 2. Does that make sense?
What about the case?
So in the case of method 3, you always call the initialized types method 3. So what was on the right side of the equal sign. Yeah. And you'll only deal with virtual inheritance in this class. So you don't have to worry about non-virtual. Yes?
Just to clarify, if we initialize sleep variable 1 equals new fog, and then we call method 1, which method 1 would it use?
Okay, sorry. So you said sleet star v equals new fog.
Yes.
Okay. New fog. And then you said v
Method 1.
method 1. Okay. Okay, so in this case, so we kind of go over here. So we see, okay, this works because fog is a subclass of sleep, so that's good. So then we could say, okay, sleep has a method 1, so this is not a compiler error. Then we go to fog and we see what method 1 does fog have. Fog has its own method 1, so we call fog method 1. Yes?
And if you wanted to call method 3, you would have to use casting.
So if we want to call method 3, we have to use casting. Actually, we wouldn't because Snow has a method 3, which means that Sleep has a method 3 because Sleep inherits method 3 from Snow. Does that make sense?
Yeah. And then if you call method 3, it will still create the fog. But it
Yes.
will be fog.
Right, exactly. Yeah.
So if the subclass inherits all the messages of the superclass, the only reason we would use this snow column is if we've overwritten method 2, right? In whatever subclass is we want to use, so previously was. Is that correct?
Yeah, so the question is, since you already inherit all of the methods from your superclass, the only reason you call like Snow : is if you wanted to specifically call like that code in Snow, and we think that might have been overridden. So exactly. Anytime you want it to actually be Snow's method 3 and not just like the generic method 3, you would call Snow : method 3. Yeah. Yeah, so the question is, can you give some examples of when it'd be a compiler error? So one example would be if you had something like snow star like v2 equals new sleet. And then if we wanted to call like v2 arrow like method 1, it wouldn't work because Snow doesn't have a method 1, right? So the compiler would be like, oh, Snow doesn't have a method 1, so I'm not going to let this compile because all I know about this variable is that it's it's of type snow. Yeah. Yeah, so the question is, so then this would be the case where you'd cast V2 as sleep, and exactly. Yes.
And so, in the sleep method, if we want to, sorry, in the sleep class, we want to have a new method which just doesn't exist in the super class. How do we do that since it will have a compiler error? It's not snow.
So,
Say we want to create a method for example.
Okay.
And like independently, right? But it's not in snow. How can we do that without having a compiler error?
So the question is, let's say we wanted Sleet to have like this other method for. How can we do that without having a compiler error? So you can get around that with casting, or with, you never call method for on objects that are declared to be type snow. So if you want to use a method for, then you have the variable be of type Sleet instead of type snow on the left side. So
How's it different from the patent, the suing thing, for example?
the
The
what thing?
The sue method is
Mhm.
the lawyer.
Yeah.
It's a new method. It's not an employee. How's it different?
So that would be exactly the same. Where like you can't call Sue on an employee, right? You'd have to call Sue on something that's declared to be of type lawyer. Yeah, exactly the same. Yes. Yeah, so you can't call method 1 on V2 because what the compiler is going to do is it's going to go and says like, oh, I have something of type snow. Type snow has a method 2 and a method 3. So if we call method 1, it's on snow, it's like, I don't think snow has a method 1, so I'm not going to compile. Even though Sleet has a method 1, the compiler is not smart enough to know that like that object behind the scenes is a right. So the question is, but like I thought you just said that if it means like the object is initialized as, and it does once it's running, it will run as the object it actually is, but in order to compile, it compiles as the object it's declared as, the type it's declared as. Right? So they're kind of like two different stages. Yeah.
Can like one class inherit like two, can it have two super classes?
So the question is, can a class inherit from two different classes? In C++, yes, but it's really uncommon. No. Cool. Yeah, because it gets into really weird behavior of like if both classes have a method 1, which method 1 do you use? Okay. We're going to do some examples too. So then we talked a little bit about typecasting, but if you have a typecast, what happens is that the declared type becomes whatever you cast it as. So if the cast type still doesn't have that method, then it's still a compiler error. If you cast it to something that it's not actually, like if you cast a programmer to a lawyer, then you get a then you get a crash. So the only way you can ever get a crash is through casting. And then assuming you don't crash and you don't get a compiler error, you still execute the object's initialized type. So if you were to cast a patent lawyer to a lawyer and then call Sue, it would call the patent lawyer's Sue, not the lawyer's Sue. Okay. So yeah, basically this will only prevent compiler errors. It won't change the output, except like it might cause a crash. So, okay. To summarize kind of what we've been talking about, so when you see one of these lines of code, the first thing you want to say is this variable cast to something? If it is, and if the casted type is a superclass or the same class as the initialized type, so whatever's on the right side of the equal sign, then like we just say that the declared type is now the casted type. If it's not, then it will crash, right? So if we were trying to cast a sleet to a fog, then it would crash. Then we say, does the declared type or superclass define the method that we're looking at? So, if we're trying to call sleet's method 3, we'd say, does snow or sleet have a method 3? And if it does, then we use the initialized type, what's on the right side of the equal sign, and we run that type's method 3. Otherwise, we have a compiler error. So this kind of just summarizes what I'd been saying on the previous slides. What questions do you have about this? Yeah.
If we were to define snow pointer equals new plots, and we were to follow that same method to it would use the most recent method to write the most recent
Yeah, so if you were to say V method 2, so in this case, we'd say, okay, does snow have, so it's not casted, does snow have a method 2? It does. And then since it does, then we go down to fog and say, what is fog's method 2? So fog doesn't have a method 2 implemented here. So then we say fog inherits from sleet, so we go to sleet and see sleet does have a method 2, so we call sleet's method 2. Yes.
Can you go back to the last slide where you had the snow, rain?
Yeah.
So, like, sleet is not a member of rain. So, like, why does it work? Because the thing that you did before when we had the programmer and the lawyer, you said it didn't work because the programmer wasn't.
Yeah. Yeah. So the question is like, so we have a snow and a rain, and then we cast this object to a sleet, and sleet is in a different branch of our tree, of our inheritance hierarchy, than rain is. So why does this work? It actually doesn't work. It's just like an example of the sort of thing you would see. So yeah, the output would actually be that it would crash.
So the object is the one on the right. Rain.
Yeah. So the initialized type is rain, the declared type is snow, and the casted type is sleet.
You compare the casted type to the initial.
Right. So you'd compare sleet and rain. Yeah. So the question is, this would just crash, not have a compiler error? Yes. So you would first check for the compiler error, which is like, does sleet have a method 1? And it does, so then it would crash. Cool. We're going to do some examples too. Okay. So, okay. Let's say we have something like this, where you have snow and rain, and we want to call method 1. So what is the declared type? Okay, so our declared type is snow. What is our initialized type? Yep. Okay. Okay. So does snow have a method 1? No. So then what happens? Yep, compiler error. Okay. So let's say we have, this var3. So what's our declared type? Okay, what's our initialized type? Okay. So does snow have a method 2? Okay, so then we're going to call method 2. So we go down here. So what is rain's method 2? It prints out rain 2, right? So, okay. Okay. What if we were to have something like this? So what's our declared type? Okay. What's our initialized type? Okay. So now we say, okay, var1 method 2. So snow has a method 2, so we go down to sleet's method 2. So sleet's method 2, the first thing it does is it prints out sleet 2, right? And then the next thing it does is it calls snow : method 2. So where do we go now? Yeah, so now we go up to snow's method 2, right? And so then we print out snow 2, because that's what snow's method 2 says. So that would be this one. What questions do you have about those 3 so far? Yeah.
So even though it's declared as a snow, when you call the method 2, like it knows that it's a sleet and it executes a sleet, even
Yeah.
though it's like a pointer
Yeah, so the question is when you call method 2, it just knows that's a sleet. Yes, that is polymorphism. Like that's it. Cool. Okay. So, okay, now let's move on to a casting example. So we have snow. So our declared type is snow, right? Our initialized type is rain. What's our cast type? Okay. So rain is it. Okay, so first off, does rain have a method 1? Yes. Okay, so it's not going to be a compiler error. Is rain a subclass or the same class as rain? Yes. Okay. And then, so let's call method 1. So what gets called? Yeah, rain's method 1, which prints out rain 1. Yeah. Cool. Okay. So initialized, declared. Okay. What's our cast class? Yep, sleet. And then is fog a subclass or the same class as sleet? Yes. Okay. Does sleet have a method 1? Okay, so it's not a crash and it's not a compiler error. So then when we call method 1, we call fog's method 1. So what's printed out? Fog 1. Yeah. So what is the question? Okay, so the question is like, why did it print out fog 1 instead of sleet 1? So casting won't change the initialized type, it only changes the declared type. So there's no way to make it call sleet 1 instead of fog 1. Like the only way to do that is to like actually make a new object that's of type sleet instead of type fog. So casting doesn't change the actual output, it only changes like what's legal to call, basically. So like it's not changing that object behind the scenes, it's just saying what it's a type of. Does that kind of make sense?
And like, so if you had a sleet that called a fog, could you cast the snow with that?
Sorry, so if it was like this, like sleet, and then can we make this snow? Yes, you can do that.
So
You'll
because snow is under fog.
Right. So the question is like, could you do this? So yes, because you would still ask the question of like, is fog a subclass or the same class as snow? Yes. Snow doesn't actually have a method 1, so this would be a compiler error, but it'd be a compiler error because of the method 1 thing, not because of the snow and sleet thing. Does that make sense? Yeah. Yes.
Why is it that snow is the initialized type and fog is the declared type?
Sorry. Declared. Initialized. Sorry, good catch. Cool. Yeah.
So what if you do like you cast it as a sleet and then you do sleet : method 1? Then can you make it like, or is there any way for you to make this object execute sleet method 1?
So the question is there any way for you to make this object execute sleet's method 1? I don't think that there is. Yeah, I'm pretty sure there's not a way to make this object execute sleet's method 1, short of making fog's method 1 call sleet's method 1. There are a couple more questions, so just really briefly. This one, declared, initialized, cast. So because the initialized class is in a different branch of the tree as the casted class, this would be a crash. And then in this one, if we were to have a method 4 that called method 2, when we call method, so here, declared, initialized, when we call method 4 on bar 8, you would go to sleet's method 4, which inherits from snow. So then this would print out snow 4. Oops. Snow 4. And then it would call method 2, and it would call Sleet's method 2, because behind the scenes, this object is a Sleet object. So it would pronounce no for Sleet 2. Cool. Thank you so much. If you have questions, come up and see me after class. Yeah, so the question is, if Sleet didn't have a method 2, then it would use Snow's method 2. Cool. Yeah, sorry for going a minute or two over.